Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 103, binary tree zigzag level order traversal. In this video, we're going to share a solution based on a very common pattern. So actually you can use this pattern to get level order traversal or zigzag level order traversal here. First, I'll read through the problem statement, and then we do the analysis, and in between, we explain the code. First, the problem statement. Given the root of a binary tree, return the zigzag level order traversal of its nodes values. So in other words, from left to right, and then right to left for the next level, and alternate in between. So here is one example. For example, here we look at 3, and then in the next level we look at 20 and 9, and in the third level we're going to have 15 and 7. So the output is a list of lists. So each element in the outer level list contains the list corresponding to a level. So example 3 is a special case because this tree is an empty tree. So the constraints for this problem are the following. First, the number of nodes in the tree is in the range given by the closed interval 0 and 2000, and the node values are in between -100 and +100. So if we look at the number of nodes, so it has an upper bound that is 2000. So in other words, so we do not have a very large size problem here. So in other words, we have a much more freedom to choose the algorithm. So here I plan to solve this problem in some sort of verbose way. So here I'm going to use list comprehension more extensively. So first I'm going to make some preparations. So for this preparation, first I'm going to initialize a result variable. This is a list, and we are going to return its final state. So this is one thing. Another thing we want to treat is that we want to track the order, right? So either from left to right or from right to left. So here we can use a flag, we can use a boolean, or we can use a number, let's say +1 and -1. So here I plan to use numbers, either +1 or -1. So in between, each time you update the flag, you can multiply it by -1, right? So this is the preparation. So in this preparation, I also want to treat a special case, which is the case corresponding to example 3, or when the number of nodes is 0. So in this case, we want to treat if not root. So we're going to return the current result state. In other words, the empty list. So this is the one main step. So next step is the zigzag order traversal. So for this, we're going to make a container. So here, the container. So you can actually in between, and for a lot of other problems related to binary tree traversals, you are going to use stack. So you are going to use queue. So here I just call it container. So here we have a root, and then we are going to do the while loop, while container. So if the container is not empty, and then so we are going to make or consider the current level. So we want to check. So at the very beginning, so we need to do from left to right, right? So but at the beginning, our flag is +1. So we want to do this if flag is +1 or greater than 0. So just a check. And then what we're going to do is I'm going to introduce a temporary variable. So here I'm going to use list comprehension. So I'm going to track we are going to track the node value for node in container. So this is one case. Another case is that so if flag is -1, so what we're going to do is that so I'm going to copy this part, and then I'm going to reverse it, right? So in either case, so we're going to append the current list to the result variable, and then once we've done this, we're going to the next round we're going to do the opposite direction. So we're going to multiply the flag by -1, right? So this is our way of treating the order here. So we choose to do this. Actually, you can choose other ways, like using Boolean variables or other orders. So you can use a deck, or you can use a stack to make it make it have the behavior you would like to. So this is the case. Next, we want to update the container. So here I'm going to use list comprehension again. So I'm going to check the child for node in the current container, and for child in node left and node right. If child here, I'm just choosing those nodes that are not null. So after this, so we are ready to actually return the result. So the third step, so return the results. So I'm going to return this result. So this actually forms one form of solution to this kind of problem. So here we have a if and else block, and then with the help of this flag to alternate the order. So if you do not use this and just append this one, this is nothing but the typical level order traversal. So with that said, let's do a test. Yeah, it passes the example 1. Now let's look at the generic case. Yeah, it passes all the cases. So here actually we didn't take care of in particular the space complexity, but you can make some refinements. So that's about it for this specific problem. Actually, you're welcome to check out our channel, and there are many other practice problems related to tree traversal. We have the pre-order, in-order, post-order, or zigzag or level order traversals. So there are some other corresponding algorithms you can check from our channel or from some the internet like Wikipedia. So with that said, I guess that's about it for this video. Thank you.